Okay. Hello. Yeah. Yes. Last class, live class, we saw where we need to focus in water supply engineering. In today's class, let us see where to focus in wastewater engineering. Wastewater engineering, more of numericals. So mostly numericals questions you need to focus. Okay. Almost all of the topics are numerical oriented only. So the first topic, you know that every topic is important here. You can't say that which is not important, which is important. Just like university exams, we can't decide that. So everything, whatever mentioned in the syllabus, by default, it is, we need to focus. But there are some concepts where there is more scope of asking numerical questions. Okay, there you need to focus more. So the first we need to focus how to work out dry weather flow and wet weather flow, and then design of sewer. This is coupled with the design of sewers. How to work out dry weather flow, how to work out wet weather flow, how to link this to design of sewers. Design of sewers means finding diameter of sewer or slope of the sewer, something like that. Then your whole focus, complete focus should be there on BOD problems. All kinds of problems related to BOD are by default important. And third area in treatment, coming to wastewater treatment, right? Primary treatment, you need to focus only on grid chamber. Of course, many units are there, but they are lengthy designs. 1 mark, 2 marks, they are not so important. For 1 mark, 2 mark point of view, grid chamber is important. So wastewater treatment, where you need to focus on grid chamber, then activated sludge process, then more, I am talking about where you need to focus more, where you need to emphasize more. Then sludge treatment, then oxidation ponds and septic tanks. Topics, we are thorough with them. Definitely, we will get 2 to 3 questions from there. This wastewater treatment, and final one is effluent disposal. So we took them as the 4th topic where you need to focus is effluent disposal. So from here also is asking questions nowadays. Remaining things just have rough idea and no need to have in-depth knowledge regarding remaining topics. But these topics are very important, and more frequently they are asking questions from here. Okay? Let us see first wastewater treatment, wastewater and wastewater treatment. Then we will see the remaining topics. So dry weather flow and wet weather flow estimation. Dry weather flow, as you all know, that it is nothing but population into per capita sewage flow. But mostly per capita sewage flow is not given, but per capita water supply is given. If per capita water supply is given, from there you can find out per capita sewage flow. That's all. Nothing will be there. Dry weather flow and wet weather flow estimation. Per capita sewage flow is equal to, it is per capita water supply into factor. How much amount of water supply convert into sewage? Fraction of water supply convert into sewage. It's called factor. So dry weather flow estimation we carry out like this. Wet weather flow estimation we carry out by rational formula. Q wet weather flow is equal to air by 360, where A is equal to catchment area, I is equal to impermeability constant, and R is equal to rainfall intensity. So this question coupled with the sewer design. Sewer design means we design the sewerage system, combined system, separate system, partially combined and partially separate system. So in case of combined system, we design for combined discharge. Combined discharge is equal to Q dry weather flow plus Q wet weather flow. If it is a separate system, either we design for dry weather flow. If it is dry weather flow drain. The drain carrying dry weather flow, that is designed for dry weather flow. Drain carrying storm water, that is designed for storm water. Okay, separately we work out. Anyway, combined system means both, it has to carry both of them, dry weather flow and wet weather flow, both of them taken together. So, okay, design of sewer means finding the diameter of sewer. Q is equal to area into velocity. So area is, sewers are normally circular sewers only we use. So velocity of flow we can work out by using Manning's formula 1 by n r power 2 by 3 s power half. So using this, so many number of questions is framing. The problem here is how to find out these hydraulic flow parameters. Hydraulic mean radius. This is hydraulic mean radius depends on, right, wetted area by wetted perimeter. So finding this wetted area, wetted perimeter are little complex here. And S is equal to slope of sewer or slope of hydraulic gradient line, which is nothing but slope of sewer only it is. Okay. N is equal to Manning's constant. So from this we can find out size of the sewer. D is equal to diameter of the sewer. That's all. So I'll take one example and explain you. But normally in fluid mechanics or open channel flow, right, then generally we design for full flow, but here we design for partial flow. For partial flow, working out hydraulic flow parameters are difficult. That's where difficulty lies. But anyway, I'll explain you with the help of one example how, what kind of question they may ask in the exam. Okay. One volt gate question we'll see. We'll take one volt gate question. Yeah, let us take this question. Okay. Question could be like this. This is gate kind of question. An existing 300 mm diameter circular sewer is laid at a slope of 1 in 280 and carries a peak discharge of 1728 meter cube per day. Use the partial flow diagram. This is a partial flow diagram. This is given to you. From this you need to pick up those hydraulic flow parameters. The figure below, assuming Manning's n is equal to 0.05 at the peak discharge, the depth of flow and the velocity are respectively. When the sewers are running partially full, either they give partial flow diagram like this, or otherwise sometimes they'll give partial flow table. Question could be like this also. See now, this partial flow table is there. You can see the table now, d by d, q by q, v by v. So using these ratios you need to find out. That is the only difficult part. So whenever they ask this question in environmental engineering, you are not expected to work out these flow parameters, hydraulic mean radius, wetted perimeter or wetted area, this and all from the basics, not expected. This is, you are expected to read these values from readily available procedures like partial flow diagram and partial flow tables. That is what you need to learn. So let us see. Normally when this question was asked in the question, this question partial flow diagram, sewer is running partially full, what we do is, suppose it is running with some flow depth to d. Depth of flow is equal to d. What we do is, we try to find out angle subtended by free liquid surface with center O. From there we try to work out wetted area, wetted perimeter. This is taken as theta, this total is taken as 2 theta. So wetted area is equal to, it is r square into theta minus sine 2 theta by 2. Wetted perimeter is equal to 2r theta, or d into theta. Using this procedure we work out. But generally this is not expected when this question was asked in GATE exam, in environmental engineering course. Open channel flow, same question if they ask, you are expected to work out like this. But environmental engineering is only application part. Therefore, there are ready-made procedures are available. Using those tables, using those diagrams, you need to find out for partial flow condition what is depth of flow, what is diameter of what is velocity of flow in the sewer, this kind of things. Okay. Let us take one example and we try to solve the question. So now this question is calculate the diameter of a circular vitrified clay sphere. Okay, this first part is okay. Second part, when flowing full at a slope of 1 in 1000. First part answer is that is the diameter we got 0.3 for example. If the flow were at 0.6 depth, what would be the discharge and velocity in the partially flow sewer? So first part diameter we got, already we know how to calculate. So when flow were at 0.6 depth, what is the diameter of the sewer? So d by d is equal to 0.6 then. 0.6 depth means d by d is equal to 0.6. Again is d by d 0.6. What is q by q value? 0.54. What is v by v value? 0.88. So using that you can work out. So that is how you need to work out the problems when you have been asked to find out, right, in this course. So at d by d is equal to 0.6, q by q is equal to I forgotten. And v by v value, whatever v by v value is given, whatever q by q is given, that is taken here. Okay. So how much is given there? Q by q, d by d 0.6, 0.54, 0.88. 0.54, 0.88. That's all. Using that values you can find out. 0.54, 0.88. So we already got diameter of the sewer as 0.3, first part, that is when running full. When running partially full, what is the diameter, what is the flow velocity, what is discharge. So discharge running partially full is equal to, it is 0.54 times capital Q. 0.54 times capital Q. Capital Q given in the question is this 0.05 Q max. Therefore this become answer 0.027 meter cube per second. Similarly, velocity of flow when running partially full is equal to 0.88 times when running full. Running full we know how to calculate. So 0.88 times running full means 1 by n r power 2 by 3 s power half. When running full it is d by 4. If we substitute these values and multiply that value with 0.88, we will get when running at partial flow condition what is the velocity of flow, you can comfortably work out. That is how we need to approach the problem. Clear? In addition to that, what else expected is sometimes and one time in, suppose a simple problem in they ask you are expected to work out from here, right? Sometimes a question could be like this also. If we say a circular sewer of diameter d, if the depth of flow is d by 4, what is the wetted perimeter equal to? Wetted perimeter is equal to 2r theta. So when it is running partially full, the depth of flow is equal to d by 4, what is wetted perimeter is. So in that case there is no option, you have to work out from basics only. There is no option left with you. Okay? Something like this. When depth of flow is equal to d by 4, this is d is equal to d by 4, this half depth is equal to, this is d by 2, then this remaining also become d by 2, d by 4, d by 4 plus d by 4 is equal to d by 4, this is diameter of sewer. So in this case, how to find out wetted area, wetted perimeter? Wetted area is asking. A wetted perimeter, P is equal, what is P value? P is equal to 2r theta, which is equal to d into theta. Okay, theta value you have to find out. This theta is equal to this. So if you take cos theta here, this is d by 2, this is d by 4. So cos theta is equal to cos inverse. It is d by 4 by d by 2. Adjacent side by hypotenuse. Okay. Adjacent side by hypotenuse is equal to cos theta. Theta is equal to cos inverse of that. So it is 60 degrees. So it is equal to pi by 3 radians. So d into theta. Theta is equal to pi by 3. Therefore it has become pi d by 3. This type of questions also possible in exam. So finding the simple things, of course, whenever you are expected to work out not wetted perimeter, something like that, you are expected to find out velocity of flow or discharge in the sewer, otherwise diameter of the sewer, not the other parameters. Okay. Generally in open channel flow means they will ask like this. This is what you need to identify. Open channel flow, same question when they ask, then how to approach the problem. The same question they ask in this course, then how to solve the problem. That idea should be there with you. That's all. Okay? Confusing you? Is it clear to you? So in addition to that, other parameters also you are expected to link. Then Q full by Q partially full ratios. Or Q full by Q partially full, or otherwise partially full condition we take small q, right? So you can write any of the parameters were expected here. Small q by capital Q is equal to, it is small a into small v by capital A into capital V. Small a into, it is velocity of flow is equal to 1 by n, right? R power 2 by 3, it is partial flow condition, S power half, this partial full condition. For full flow conditions, capital A into 1 by n, R power 2 by 3 into S power half. This S R is different, this S is different. This is for partial flow, this is for full flow. That ratios they will ask you sometimes. Okay? That ratios, any parameter. Suppose the areas are same or N's are same, R's are same, then what is the relation between S partial full to S full? Or if slope is same, diameter is same, and what is the ratios of R of partial full condition, R of full flow condition? Or when slope is same, diameter is same, if n value changes, what happens to discharge? Like this, different things you are expected to work out. How to link them? Because Q value depends on all these parameters. It depends on A, it depends on N, it depends on R, it depends on A. R in turn depends on wetted area by wetted perimeter also. So it all depends on so many number of parameters. So they try to link questions based on these parameters. Q full to Q partial full, Q partial full to Q full, V partial full to V full, something like that. This way also you are expected to find out. V by V. So V is equal to 1 by n into R power 2 by 3 into S power half. This is for partial flow condition, small v. Capital V for full flow condition, 1 by n R power 2 by 3 S power half. This is for full flow condition. Clear? So link between these parameters are expected to work out. That is how they frame questions in GATE exam. Okay? Linking the parameters. Just blindly mug up the equation, it is of no use. Which parameter is dependent on which parameter? Suppose velocity of flow, you take velocity of flow is dependent on R value, velocity of flow depend on S value. If R value changes, what happens to velocity? If S value changes, what happens to velocity? When flow condition changes, what happens to these parameters? That is how you are expected, they frame the questions. Then if you know basic equation, how to link them, you can easily guess what kind of questions they may ask from in the exam. Couple of questions you practice linking them, then you become familiar, then any kind of question they ask comfortably you can answer. Okay? This kind of questions they will ask. Next, coming to BOD problems. I am writing straight away BOD problems. Very important topic this is for GATE exam and as well as any kind of competitive exam. So BOD problem straight away, laboratory equation is different and mathematical model for BOD equation is different. Laboratory equation is 5 day BOD at 20 degrees Celsius is equal to, BOD always measured for 5 days at temperature 20 degrees Celsius. We write like this, 5 day BOD at 20 degrees Celsius is equal to, it is dy initial minus dy final into dilution factor. The laboratory, right, we take a sewage sample that is mixed with the distilled water. We prepare diluted sample. Distilled water contain dissolved oxygen. The dissolved oxygen used by the bacteria present in sewage sample. So how much amount of oxygen they consume? That will give you fight. Because we are taking diluted sample, we apply correction for dilution. This dilution factor is equal to, it is 300 by Vs or otherwise 100 by percentage dilution. Or percentage sample is taken or percentage sample. That way also you can find out. Okay? And dy initial sometimes you are expected to work out. So you have two different samples you are taking in BOD bottle. So some is sewage sample, VSML is sewage sample is taken, remaining is filled with distilled water. This is distilled water. VDML of distilled water, sewage sample this is. This is sewage sample. Remaining is filled with distilled water. this bottle. We prepare like this, BOD bottle. Okay? Whenever the sewage sample, bacteria present in the sewage sample require oxygen, it get from distilled water. It is fully saturated with the oxygen, DO. Sewage sample may contain little DO, may not contain also. So it may be DO levels of sewage sample may be 0 sometimes, little maybe it may contain little, but that is not sufficient to meet high oxygen demand of bacteria present in sewage sample. So bacteria require two things for their survival. One is food, other one is oxygen. Food is available in the form of sewage sample. So what else is required is oxygen. That oxygen demand we have to meet externally by supplying oxygen to them. That oxygen we enrich, we supply that oxygen to bacteria, right, by saturating distilled water with a sufficient amount of oxygen. So whatever oxygen present in distilled water, that is used by the bacteria and it survive till the end of the test. So this test is conducted for 5 days, right, 5 days at 20 degrees Celsius. So sometimes you are expected to find out initial DO, two different samples having two different DO values, you are diluting here, therefore you are expected to find out initial DO. So DO initial is equal to, it is two different samples, VD into DOD plus VS into DOS. Using mixed formula you can find out, VD plus VS, DO initial. DO final he has to give. So knowing the initial DO, knowing the final DO, we can find out what amount of oxygen that microorganisms utilize in that 5 days at temperature 20 degrees Celsius. So this is linked to numerical, that mathematical model also sometimes. What is mathematical model? So 5-day BOD at 20 degrees Celsius is equal to it is DO initial minus DO final into dilution factor, which is also, sorry, the mathematical model I am talking. It is L0 into 1 minus e power minus k20 into 5. So these both of them are equated. So using this you can find out L0 and as well as k20 by equating laboratory model to this one. In this L0 is equal to ultimate BOD. You are expected to work out ultimate BOD and k20 value. For one time you test sewage sample, right? We get this, we can find out these values. So we can equate these two equations. Based on this, you'll frame questions in the exam. DO initial into DO final into DO initial minus DO final into dilution factor is equal to, it is L0 into 1 minus e power minus k20 into 5. So this data may be given, you are expected to find out L0 or you are expected to find out BOD at any time at any temperature. So BOD at any time at any temperature is equal to, it is L0, once L0 is known, from that you can find out L0, K at any temperature into T. Using this expression you can find out BOD at any time at any temperature. This kind of questions they'll ask. For example, I'll take one example. Right, in a BOD test example. In a BOD test, on 5% sewage sample, right? 5% sewage sample, 5%, okay? 6 milligram per liter of DO is consumed, DO is depleted. Then find a BOD at a temperature 15 degrees Celsius for the same sample. So K20 is equal to 0.23 day inverse to the base E. A question is asked like this. If question is asked like this, how to approach the problem? Laboratory test details are given to you and you are expected to work out something related to BOD using that mathematical expression. Without mathematical expression, it is impossible. So such type of questions are possible in GATE exam. So what to do in this case? How to link them? So what is given is, straight away as given, DO initial minus DO final is equal to DO depleted or DO used. DO used or DO depleted. Who depleted? Who used DO or DO consumed? Consumed DO? Microorganisms. All of them same. So this is given. This is given as how much? 6 milligram per liter. Yes, given in the question, 6 milligram per liter. Right? What is the dilution factor for this? So dilution factor is equal to 300 by Vs or 100 by percentage dilution. Here 5% sample, no? This is 5%, 100 by 5. Therefore, 5-day BOD test means by default 5-day BOD at 20 degrees only. No need to write again. Is equal to, it is DO initial minus DO final into dilution factor. This is given 6. This is 100 by 5. So it is 120 milligram per liter. 5-day BOD indirectly given in the form of test data. 120 milligram per liter. But he is not asking 5-day BOD. He is asking 3-day BOD at 15 degrees Celsius for the same sewage sample. How to find out 3-day BOD for 15 degrees Celsius for same sample? BOD at any time at any temperature is equal to, it is L0 into 1 minus e power minus k T into T. So 3-day BOD at 15 degrees Celsius is equal to, it is L0 into 1 minus e power minus k 15 into 3. This is the equation. But what is required here? L0 is required and K15 is required. So K at any temperature you can write it as, it is K20 into 1.047 into T minus 20. Using this expression you can find out K at any temperature. Therefore K15 is equal to, it is K20 is 0.23, 1.047 into 15 minus 20. Come on, work out this value, how much it is, quickly give me. I have to try and better you try. (1.047) to the power minus 5 into 0.23. So it is 0.182 it is. Once you get this, you can link them. So what you got? 5-day BOD at 20 degrees Celsius is equal to 120 milligram per liter, from which you can find out L0. Isn't it? So from once you know L0, then you can find out 3-day BOD 15 degrees Celsius is equal to L0 into 1 minus e power minus k 15 into 3. So in both of them L0 is same. Therefore I take L0 constant, which is equal to 5-day BOD 20 degrees by 1 minus e power minus k20 into 5, which is also equal to 3-day BOD 15 degrees Celsius, because L0 is constant. L0 is ultimate BOD, which is constant at any temperature or at any time. So that's all. Then by linking these two you can find out. So it is 120 by 1 minus e power minus 0.23 into 5, which is also equal to y3 15 degrees Celsius 1 minus e power minus 0.128 into 3. Come on, simplify, we'll get 3-day BOD at 15 degrees Celsius. So at any temperature you can work out, at any time you can work out BOD. So 120 by, you also try. I got this value is 175.6 into 1 minus 0.182 into 3. Today BOD at 15 degrees Celsius. It is 73.88. Definitely 3-day BOD at temperature is less, time is also less. Definitely 3-day BOD at 15 degrees is much less than 5-day BOD at 20 degrees Celsius. So what I mean to say is that BOD concept should be clear to you. So this is the ultimate BOD, L0. L0 is nothing but ultimate BOD. As temperature changes, speed of reaction also increases. Suppose this is 20 degrees curve. If a temperature is more than 20 degrees, curve will be like this. This temperature is greater than 20 degrees. Temperature is less than 20 degrees, curve will be like this, less than 20 degrees. So as temperature changes, things will change. Same time you work out different temperatures, different BOD values will get. Same time. So at temperature less than 20 degrees, this much BOD will get. This BOD versus time plot, this is. At 20 degrees, this much BOD will get. At more than 20 degrees, this much BOD will get. Right? Temperature may be constant, time changes, things will change. Time to time, things will be changed. Or two different temperatures, as time changes, BOD value also changes. So this is kind of questions they'll ask. This is some time, T1 time, this is same temperature, T2 time, if work out 5-day BOD, it will be different. Similarly, more than 5-day BOD, it is different. Temperature more than 20 degrees, different. So something like that. So this kind of questions they will ask. So sometimes what it does is, confuse you with the terminology. So in this curve, if you see, this is ultimate BOD, this is BOD exerted, BOD removed. That means oxygen demand met. This is BOD removed, and this is BOD remained. It will confuse you with this terminology. Demand remained, demand removed. This is ultimate demand. This ultimate BOD means ultimate oxygen demand. So BOD versus time plot, if you see, with the terminology will confuse. BOD remained, BOD removed. Sometimes we will ask remained, sometimes we will ask removed. Remained means it is LT, removed means it is YT. So YT, LT. LT is different, YT is different. So we got equation for LT. BOD remained at any time T is equal to, it is L0 into e power minus K into T. This BOD remained and organic matter remained, both of them are one and same. Right? BOD remained and organic matter remained, both of them are one and same. BOD removed and organic matter removed, both of them are one and same. You can see this. This is organic matter versus time plot. Right? This is BOD versus time plot. So BOD curve, oxygen demand we supply externally like this. But whereas when you supply oxygen like that, organic matter initially high amount present, it decreases like this. See, these both curves are same. So when you are talking about this is called organic matter removed. Initially L0 amount of organic matter present. Organic matter remained at any time T is equal to, it is LT. This concept is only tricky concept. This is LT. Then if this is LT, what is this? This is L0 minus LT. So this is also LT then. And this we took it as YT. So this YT, L0 minus LT, both of them are same. So this YT is equal to L0 minus LT. So LT is equal to L0 minus this one. That's why we got equation L0, if you take common, it is 1 minus e power minus KT. Understood now? YT is equal to L0 minus LT. So L0 minus L0 into e power minus KT. So if you take L0 common, it is 1 minus e power minus KT. That's how we got this equation. So sometimes we'll ask LT, sometimes we ask LT. So this and this are same. When you are talking about organic matter, food consumed, oxygen consumed, both of them are same. Food consumed, oxygen consumed, both of them are same. Human beings and microorganisms difference is, human beings consume less oxygen, human beings consume less food, more oxygen. This much amount of oxygen we consume, but food consumption is only this much every day. But whereas microorganisms, their oxygen consumption, their food consumption, exactly proportional. Therefore, if you know their oxygen consumption, indirectly we can find out their food consumption. That's what we try to do. We try to link between these two with the help of BOD equation. Okay, BOD questions are very, very popular. So this equation related to this equation and laboratory model, both of them are very, very important for exam point of view. Okay. In addition to that, one more extra thing that in BOD topic is population equivalent. Sometimes you are expected to work out population equivalent of the waste. So this population equivalent is the concept used by municipal corporation to charge this whenever they offer service, whenever they treat the waste produced by the other sectors other than domestic sector. So they give service to them based on the payment. That payment component they work out in terms of population equivalent. So population equivalent is a concept used by municipal corporation. So normally that payment component they work out not based on volume of waste they treat. It is based on strength of the waste they treat. So volume of the waste means sometimes an industry, suppose an industry, right, when it utilizes municipal treatment system, they produce huge amount of waste whose BOD may be very small. That waste can easily be treated. Some other industry produces small amount of waste whose BOD is very, very high. That waste is difficult to treat. In such case, if you on volume basis, if you charge them, that's unfair for a person who produces, right, huge amount of waste with a little BOD. Its waste can easily be treated. The person who produces less amount of waste with very high BOD, that waste is difficult to be treated. That fellow is charged less, this fellow is charged more. So that is unfair to the person whose waste is easily to be treated is charged more, that is unfair. Therefore, to charge everybody equal, we don't charge them based on volume of waste they produce. We charge them based on strength of waste they produce. That strength of waste is measured in terms of BOD. We all know that BOD is a strength parameter. So we have that strength of waste also we convert into equivalent strength of domestic waste. Domestic waste is contributed by population. Therefore, population equivalent of that waste. So a person producing a waste, an industry, suppose for example, an industry producing a waste whose population equivalent is equal to 1 lakh. Some other industry producing a waste whose population equivalent is only 10,000. So per person I will charge 2 rupees or 3 rupees, something like that. The person who produces waste whose population equivalent is 1 lakh, he has to pay 3 lakh rupees to me every day, to the municipal corporation, for giving the service to them for treating his waste. The person whose waste, whose population, the industry whose population equivalent is 10,000, they have to pay only 30,000 rupees. So for everybody treated equally. If you work out, if you charge them based on population equivalent of their waste. Therefore, population equivalent is equal to total BOD of any waste by per capita BOD. Okay, total BOD means Q into 5-day BOD. Per capita BOD, that depends on food habits of the people. As per IS code, in India, per capita BOD of Indian populations is, it is 70 to 90 grams per person per day. So total BOD work out this, you substitute in MLD, this in milligram per liter, straight away this product will give answer in kilogram per day. And per capita BOD also work out in kilogram per day. Both of them will cancel out, you will get population number. The waste is equivalent to what number? So let us take one problem, for example. Industry producing MLD of wastewater with a 5-day BOD 200 milligram per liter. Find population equivalent of that industry. Population equivalent of the waste. If per capita BOD is 80 grams per person per day, like that they express. Okay? Yes, given. So you have been asked to find out population equivalent. Therefore, population equivalent of this waste is equal to total BOD of that waste by per capita BOD. Q into 5-day BOD by per capita BOD. This is how we can find out. So 50 MLD into 200 by 80 grams. I am converting grams into kilograms. That's all. They'll cancel out. You can use calculator. Calculator is allowed in GATE exam. Okay? Don't waste your time. So it is 50 into 200. Also using calculator only. By 80 into 1000. So it is, his waste is equivalent to 1,25,000 people's waste. That is how we work out. So even you charge 1 rupee, right, how much he has to pay, that industry has to pay every day to municipal corporation? 1,25,000 rupees. That depends, that they will decide. That per capita charges decided by municipal corporation, what kind of technology they apply, right, what kind of maintenance is there, right, the office staff, salaries of office staff, everything they calculate and then work out per person how much they are supposed to charge. Normally its charges are very less only, 50 paise to maybe maximum 2 rupees, not more than that. Okay, that's it. This kind of questions they will ask in BOD topic. So mainly BOD equation and that laboratory questions. Laboratory equation, mathematical equation, both we try to link and ask some question. Okay, that's all. Next, coming to wastewater treatment. Wastewater treatment, we all know that it is divided into preliminary treatment, secondary treatment, sludge treatment, tertiary treatment. So many things are there. In primary treatment, if at all they ask any question, that is only from grit chamber. Screens, this and all not required. Okay. In grit chamber is exactly same as, right? It's a design concepts exactly same as design of sedimentation tanks. Therefore, more questions they are asking from here. Grit chamber. So grit chamber design is based on 2 parameters. One is detention time. The other one is horizontal flow velocity. Horizontal flow velocity we maintain in grit chamber is 0.3 meters per second. Detention time we provide is 1 to 3 minutes. We all know that whenever detention time is given, we are expected to find out volume of any kind of system. Volume is equal to Q into detention time. Grit chamber is a long, narrow, rectangular channel. Therefore, it is rectangular channel. Its volume is equal to, right? Its volume is equal to L into V into H. So, if you know VH, what you can find out is cross section area of grit chamber. Cross section area. So, it is Q by VH. Cross section area is nothing but B into H. So, B into H you will get that, and length of grit chamber you can find out. It is Q into using these 2 parameters, VH into detention time. Length of grit chamber will get. So length you got, cross section area you know, then B is to H relation is given to you. From there you can find out dimensions of the grit chamber. It is not only dimensions, so many number of things also expected. For 100% removal, condition for 100% removal of grit chamber also they can use. Like sedimentation tank. Condition for 100% removal of grit. What is the diameter of the particle that is, the grit particle that is to be removed completely from wastewater? That's how they ask. So, first condition is Vs should be greater than or equal to V naught. Second condition is H by Vs should be less than or equal to L by Vh. Minimum condition you can take and find out H by Vs is equal to L by Vh. So, from this equation you can find out Vs. Vs is equal to Vh into H by L. So, this Vs is nothing but G into S minus 1 d square by 18 nu. Then you can find out diameter of the particle that will be removed completely, 100% removed from grit chamber. This is also a very popular question in GATE exam. So you will link these concepts. So you are expected to find out dimensions and then what is the diameter of the particle that is completely removed from grit chamber. Then you can use 100% removal condition, you can link them, you can find out. Once the dimensions are known, Vh into H by L is equal to this equation, you can equate and find out diameter of the grit particle that is removed completely from wastewater. Such type of questions also they are asking. I will show you one question. Last year GATE, this year GATE exam also one question came. Okay, I will show you. The following data are given for a channel type of grid chamber. Length is equal to 7.5. Flow through velocity is 0.3. Depth of flow is 0.9. Specific gravity of grid is 2.5. G is 9.8. Dynamic viscosity is 1.002 into 10 power minus 3 Newton second per meter square at 20 degrees. Rho W is 1000 kilogram. Assuming that Stokes law is valid, the largest diameter of particle that will be removed 100% efficiency is. That's how questions they'll ask. So what you need to do, here everything is given. You need to work out just what is the diameter of the particle that is removed 100%. Let us solve this question. So what is given to is length of the grid chamber is given as 7.5, flow through velocity is 0.3, right? Depth is given as 0.9. Okay. The length of grid chamber is given as 7.5 meters, depth is 0.9 meters, flow through velocity is given as 0.3 meters per second. Specific gravity of grid particle is given as 2.5, G is given as 9.8 meter per second square, rho W is given as 1000 kilogram per meter cube, right? What else is given? Dynamic viscosity is given. Dynamic viscosity is given as Dynamic viscosity is given as 1.002 into 10 power minus 3. 1.002 into 10 power minus 3. What is the diameter of the particle that will be 100% removed is asking. So what you need to do here, for 100% removal conditions are there. Which condition you can use? First condition or second condition? Second condition you can use because you need to find out diameter of the particle. Therefore, H by Vs should be less than or equal to L by Vh. So minimum condition you take, you can equate H by Vs to L by Vh. Therefore, Vs is equal to Vh into H by L. Vh is given as 0.3, H is given as 0.9, L is given as 7.5. This is also meters per second. This you can equate to normal regular equation. Vs is equal to G into, because dynamic viscosity is given, so you can use this equation, rho P minus rho W, d square by 18 mu. Equation is there. Then if you equate, then you can find out what is the diameter of the particle that is removed 100%. Even 2021 GATE exam also one question came from the same procedure, same way. 0.3 into, only parameters are different, dimensions are different, that's all. So substitute 9.8 rho P, density of particle is equal to specific gravity of particle into rho water. It is 2.5 into 1000. Then it is 2500 kilogram per meter cube. So 2500. Substitute will get answers. Okay. 1500 minus 1000. D is unknown. D square 18 mu 1.002 into 10 power minus 3. Come on, tell me answer now for this question. We'll get answer in meters, then you can convert into whichever unit system you like. Then we work out answer. The answer is, it is 2.1 into 10 power minus 3 or minus 4? It's 4 mm, which is equal to 0.21 meters, sorry. Meters, which is equal to 0.21 mm. That's how we can calculate. Clear? Let us have a small break, of 5 minutes break. Again we'll meet after the break, okay? I'm little thirsty, let me drink some water. Yeah, shall we move ahead with next topic, biological treatment? In that very, very important topic is activated sludge process, okay? Next, you need to focus more on activated sludge process. Activated sludge process is completely formula driven. So, the formula you have to remember, our F by M ratio, we'll ask questions, mean cell residence time, theta C, then sludge volume index. These three are very, very important. Sludge volume index, nowadays is asking sludge density index also, couple of times in GATE exam. So these parameters, if you know how to work out, then more than sufficient in activated sludge process, okay? Of course, so many are there in addition to that. So what you need to remember is F by M ratio is equal to, it is Q into Yi minus Ye by V into X. So whenever F by M is given, you are expected to find out volume of aeration tank. Whenever volume of aeration tank is given, you are expected to find out F by M. That is how they frame the questions. Okay? This one equation you have to remember. Sometimes this Yi and Ye is given in terms of Si and Se. I mean substrate. Substrate means food only. This means substrate, yes. Nothing but food. Food is nothing but BOD. BOD only it is. Okay? That's why I took it as Yi by Ye. So some books, they take Si and Se, don't confuse, okay? Both of them are same only. This X is equal to MLSS. Sometimes it is MLSS, sometimes it is, we take it as MLVSS. So whenever we talk about microorganisms, MLSS include MLVSS as well. 80% of MLSS is MLVSS only. So whenever both of them are given to confuse you, whenever we talk about microorganisms, use MLVSS. In general, solids we use MLSS. Okay, generally F by M ratio we use MLVSS. Or only MLSS is given, no confusion everywhere, we use MLSS only. Okay, don't get confused with this. This is the one. So whenever F by M is given, for given F by M, you are expected to find out so volume of aeration tank. Whenever volume of aeration tank is given, you are expected to find out F by M. Usually they'll frame questions there only. Whenever F by M is given, volume is expected to find out. Whenever volume is given, you are expected to work out F by M. Okay, that's one question. Then coming to mean cell residence time, theta C, which is equal to, it is V into X by QW into XU plus Q minus QW into XE. Okay? So this QW into XU plus Q minus QW into XE is equal to, it is mass of solids wasted. Sometimes mass of solids wasted also they are asking question in the exam. Right? This is a V into X is equal to total mass of MLSS, total MLSS in aeration tank. Right? This normally V value we substitute. This is in MLD, this is million liters, milligram per liter. This is kilogram per day. So kilogram per day, kilograms cancel out. Then you get with the answer in mean cell residence time in terms of days. Right? So whenever mean cell residence time you are expected to calculate, they will give you all these things. So one thing you can take 0 if required, that XC. When XC and YE is not given, so if XC is not given, if XC is not given, then you can take it as 0. Then XC can be taken as 0 because XC is nothing but MLSS in effluent. If all of the solids settle down in the secondary clarifier, then usually XC value, obviously it becomes 0. So if some of them escape, then there will be little XC present in effluent. That value, if that is the case, that value will be given to you. Okay? Similarly, in the last slide, here also, whenever Y is not given, if Y can be taken as 0. If Y is not given, if all of the B word is removed from process, then Y becomes 0. Right? If little B word remain there, then that Y value will be given to you. Using that value, you can work out. So two parameters, if not given, If required, you can take them as 0. One is XE, the other one is YE. Okay? But some books you see YE being so small, they neglect this. Then they take F by M is equal to Q into YI by V into X. Okay? Because YE being so small, they neglect Q into YI by V into X. So let them take anyway. You use proper formula. Even they take, if suppose in the examination, if they work out answer by using Q into YI by V into X, you calculate like this. Little y is there even then you end up with a little lesser value. Then we look for nearest highest value available, nearest answer available. Definitely the nearest answer would be Q into Y by V into X only. We'll tick mark that. Okay? In the exam, suppose examiner take this equation and work out, you take Q into Y by V into X, if you evaluate F by M like that, then the answer is not matching with that, then the nearest highest value you choose and you tick mark and you will go wrong. Okay? Better always use this equation. This is the one precautionary measure you have to take while working out the things. Small errors, we end up always with small errors. So this equation, sometimes we will ask volume of solids wasted, mass of solids wasted. Volume of solids wasted is nothing but, right? Nothing but QW only. Volume of solids wasted means it is QW. Mass of solids wasted means it is QW into XE. Okay? This is one equation. Then one more important thing that they are asking in the exam is sludge volume index. Sludge volume index is nothing but, it is an experiment we conduct in the lab. So we take one conical or one measuring jar, graduated measuring jar. In that we take 1 liter sewage sample containing 1 gram of MLSS. If you allow this mixed liquor suspended solid to settle down for some time, so they occupy some space here. Then from here we calculate sludge volume index. This is space occupied after 30 minutes settling. After 30 minutes settling in that jar. This 1 liter sewage sample you take here and allow it to settle down, it occupies that space. Sludge volume index is nothing but space occupied by MLSS. Space occupied we substitute in ml, MLSS we substitute in gram, therefore sludge volume index we get answer in ml per gram. Sludge density index is nothing but 100 by sludge volume index you take, you will get sludge density index. Sludge density index unit is, it is gram per 100 ml. That's how we express the sludge density index. Okay? Sludge density index unit is gram per 100 ml. Sludge volume index unit is ml per gram. Using sludge volume index, you can also find out XU. So this XU is equal to, it is 10 power 6 by sludge volume index. XU value we calculate in milligram per liter. So this many number of things we can work out using that sludge volume index experiment. XU you can find out, sludge density index you can find out. So this is how he is asking questions in the exam. Okay? In addition to this, the extra things what is expected in the aqueous sludge process, aeration period. How long that wastewater is aerated? So as long as it is present in aeration tank, it is aerated. Nothing but detention time. This is nothing but volume of aeration tank by flow rate. Volume of aeration tank is equal to length into width into depth by flow rate Q. This is how we can work out aeration period. In addition to that, sometimes BOD removal efficiency of process is equal to influent BOD minus effluent BOD into influent BOD by 100. Sometimes you are expected to find out organic loading rate or volumetric loading rate. Organic loading rate or BOD loading rate. If that is the case, this is denoted by volumetric loading rate. It is Q into YI by volume of aeration tank. This is also expected to find out, but we calculate this value in kilogram per meter cube per day. So like this, so many parameters are there in BOD, this activated sludge process system, which we use them as a design parameters to work out the dimensions of the system. Okay? In addition to that, what extra is there? Suppose what is a capacity of aerator required? So capacity of aerator required is equal to It is nothing but a pump, HP. In HP we will find out, right? Capacity of aerator required is equal to oxygen demand it's supposed to meet by total oxygen demand it has to supply. Total oxygen demand by, right, oxygen transfer capacity of aerator. This much depth is not going. Even in the ask also, you see the units, you can find out. Oxygen demand is normally expressed in kilogram per day. Oxygen transfer capacity they will give in kilogram per hour per HP hour or something like that. Kilogram per HP hour, something like that. If you see the units, you can get the idea. So this kilogram per day you convert into kilogram per hour by kilogram per HP hour if you substitute. So kilogram cancel out. HP hour cancel out, you left with HP, so and so. This kind of questions they can ask in exam. Whenever any question, whenever you stuck there, don't be panic, you don't get idea. See the units, what is given, what is expected. Maximum what they will ask in double E codes, either they ask you volumes, they ask you dimensions, length, width, depth, or otherwise they will ask areas, right, cross-section area or plan area or surface area, something like that. Or sometimes they will ask detention time. So arrange the given data, how to get those values. Suppose detention time is supposed to get in hours. How to get that, arranging the given data to get answer in hours, either to multiply or to divide, something like that. See the units, you arrange them properly, then and there you can frame equation and solve. That facility is there in this course. So just by arranging the units, then and there you can frame the equations, solve the questions. Don't give up. Even if you forget the equations and all, don't give up. Try to arrange the data, given data in the question, so that suppose time they ask, normally time we express either in hours or in days or in minutes. So how to get the answer in days or minutes or hours using the given data in the question. Okay, how to arrange them to get the answer in that time units. How to get data in surface area units, meter square. How to get the answer in volume units, meter cube. So if you just have idea, rough idea how to arrange the data, either to multiply which parameter to which parameter, which information to which information, or to divide them, so you will get the answer. No need to give up. Suppose for example you see surface loading rate is given. Surface loading rate or hydraulic loading rate, normally they give liters per meter square per day, right? So you have been asked to find out surface area. Then in addition to that, flow rate will be given, so and so meter cube per day. So how to get surface area? Surface area units must be meter square. So I need to get answer in meter square. Meter square is there here. Therefore this should be in denominator. Because this is there in denominator, denominator of denominator goes to numerator. We will get answer in meter square. Q is given in meter cube per day. That you can convert into liters per day. Convert this into liters per day and substitute this value in surface loading rate in liters per meter square per day. So if you arrange data like this, then what happens? This cancel out, this cancel out, then you will get answer in meter square. This is how you can then and there frame equations on your own and you can multiply. Suppose detention time is given. Detention time is given, suppose in hours, and flow rate is given in meter cube per day, and so you are expected to find out volume. So volume is equal to what? Volume unit is meter cube. I suppose to get answer in meter cube. There must be some parameter which cancel out days. What is that parameter cancel out days? Detention time. Convert that into days. So Q into detention time we multiply the meter cube per day or meter cube per hour into hour. They cancel out, will get meter cube. Like this, by arranging, sometimes by dividing, sometimes by multiplying, you can arrange the given data so that you can arrive at proper answer in proper unit system. Just by using the unit system, then and there you can frame the equations and work out the problems. Okay, don't give up in the exam. Even if you forget the concept, you forget anything, see the given data, how to arrange the data, whether to divide or multiply, see that, so you get answer in proper unit system. Okay. This is about actual search bar. Trickling filters generally they don't ask. Trickling filters, if at all they ask efficiency equation, NRC equation, it is 100 by 1 plus 0.0044 into root of Q into Yi by V into F, and which is also equated to Yi minus Ye by Yi into 100. So he may give you some information to work out this, and you are expected to find out FE and BOD. Or sometimes this information is given to you, you are expected to find out volume of aeration tank, volume of trickling filter. So normally this Q into Yi by V value, this is an empirical formula we express in terms of, this is kilogram per hectometer per day. So we'll get answer in hectometer, this volume. So once you get, for a given efficiency, you are expected to find out volume. For a given volume, you are expected to find out efficiency, that's all. So for a given volume, you are expected to find out efficiency. Sometimes you are expected to find out effluent BOD. For a given efficiency, you are expected to find out volume of aeration tank. So that's how questions they will ask, if at all they ask any question in trickling filter. For a given efficiency volume, for a given volume efficiency. And F is a recirculation factor. For standard rate trickling filter, recirculation factor is equal to 1. F is greater than 1 for high rate trickling filter. You have to work out that F value also. To work out F value, again one more equation is there. F is equal to 1 plus R by I by 1 plus 0.1 R by I. So they are not asking questions, numerical questions based on trickling filter, because they always go with the latest trends in technology. So trickling filters are old technology. Almost everywhere they are replacing trickling filters with activated sludge process. Activated sludge process is most happening technology, most sought after technology to carry out biological treatment, right? So therefore they are almost outdated. Therefore you can't expect a question from trickling filter in GATE exam. So GATE always go with the latest trends, okay? Okay, then let us see next topic. In addition to that, what is expected is one more important area where you need to focus is sludge treatment. From sludge treatment also they keep on asking questions in exam. Sludge treatment also very important both for all kinds of competitive exams. Here you are expected to find out one is specific gravity of sludge. Sludge is, we all know that sludge is a mixture of, right, solids and water. And solids again contain two things, volatile solids and non-volatile solids. In sludge treatment we aim to remove, we aim to destroy volatile solids and we try to reduce moisture content. Completely we destroy volatile solids and moisture content so that sludge becomes safe to dispose. That was the concept. So first thing what is expected is, you are expected to work out specific gravity of sludge or density of sludge. That is one kind of question very popular in competitive exams. So 100 by specific gravity of sludge is equal to, it is percentage solids in sludge by specific gravity of solids plus percentage moisture content of sludge by specific gravity of water. So this water content is known as moisture content. We call it as moisture content of sludge. So sludge is a mixture of solids and water. Therefore, so suppose water content is P% is water, then remaining are solids only. 100 minus P are solids. 100 minus P% solids, P% water. If you mix, then you will get a wet sludge in the form of this. Okay? Then sometimes the solids, specific gravity of solids also not given. So solids are mixture of two things, volatile and non-volatile. Any kind of mixture will work out specific gravity is like this. This equation, 100 by specific gravity of solids is equal to percentage volatiles by specific gravity of volatiles plus percentage non-volatiles by specific gravity of non-volatiles. Okay? Questions may be from asked from this. Then once you know specific gravity of sludge, sometimes you are expected to find out density of sludge is equal to specific gravity of sludge into density of water. This is very popular question in GATE exam. Just finding specific gravity of sludge. Okay? For example, we have been asked to find out specific gravity of sludge. Find density of sludge if sludge contains % solids with 70% volatile solids having specific gravity 2.2 and remaining non-volatiles with the specific gravity 2.7. When you have been asked to find out like that, when you are asked a question like that, then you have to work it out. Indirectly given everything. So 2% solid means what is percentage moisture content of sludge? That is P is equal to 100 minus 2. It is 98% is moisture content. So percentage solids are 2% is given. This is 2. 2% solids means remaining is moisture only. Okay. Similarly, volatile solids is equal to percentage volatiles is 70. Then percentage non-volatiles is 100 minus 70. It is 30%. So from this first I straight away work out specific gravity of solids is equal to 70% volatiles by specific gravity of volatiles plus percentage non-volatiles by specific gravity of non-volatiles. So from this, substituting in this, you can find out specific gravity of solids. Come on, work out. Some of you, calculators are there with you, no? You can find out easily. So 70 by, don't think that I am wasting time asking you to calculate this. 30 by 2.7. Is 2.329. Then 100 by specific gravity of sludge is equal to percentage solids by specific gravity of solids plus percentage moisture content by specific gravity of water. So 100 by specific gravity of sludge is equal to, solids are how much per present there? Given in the question only. 2% solids. Remaining is moisture content only. Specific gravity of solids we got 2.329 plus moisture content is 98% is 1. So 2 by is 1.001. I remember the values. This question we have solved in the class also. Specific gravity of sludge is equal to 1.001. Then density of sludge. How to find out density of sludge? Density of sludge is equal to specific gravity of sludge into density of water. So specific gravity of sludge is equal to 1.011. Density of water is 1000. So it is 1011 kilogram per meter cube. This is how we can find out. Okay. This kind of question that they are questions they are asking in exam. Anyway, that is easy only. Then what else? What is expected in addition to this is, so how to calculate volume of sludge? So volume of sludge produced is equal to 100 by 100 minus percentage moisture content into mass of solids produced by density of sludge. So using this expression you can find out volume of sludge produced per day in so and so meter cube per day will get. Right? This M value calculating rho P, rho sludge, this and all given to you. M is not given to you. M is equal to Q into efficiency of sedimentation tank into concentration of solids in sludge, that is Cn. If you take this and if you substitute this in MLD, this concentration of solids in sludge, right? Efficiency of sedimentation tank into Cn is equal to concentration of solids in sludge. mg per liter, straight away will get this in kilogram per day. So you suppose now how to calculate this M value. So when your sedimentation tank is there, when you apply Q amount of water with concentration of solids is Cn, then all of them will not settle down. Some of them settle, some of them escape also. The amount of solids that settle down is called sludge. Right? That concentration is Cn minus C out. Right? The C out is concentration of particles escape, which is nothing but efficiency of sedimentation tank into Cn. That's how we work out this concentration of solids in sludge. Clear now? This and all we discussed in the class also. So this is very popular question in the competitive exam, finding the volume of sludge. So in sludge treatment, we try to achieve volume reduction of the sludge. That volume reduction of sludge occur by reducing the moisture content and by reducing the solids content. So volume reduction of the sludge is equal to V2 is equal to 100 minus P1 by 100 minus P2 into V1, assuming that no change in solids content, no much change in water content. This equation you can use. No change in solids content. No much change in water content. Or very little So this equation is very popular. They are asking questions in the GATE exam. How volume reduction of the sludge occur? After sludge treatment, volume of the sludge is equal to V2. Before treatment, volume of the sludge is equal to V1. So V1 is equal to volume of raw sludge and V2 is equal to volume of digested sludge after treatment. Actually V2 and V1 separately you can find out, but we try to link between V2 and V1 to find out volume reduction of the sludge. How volume changes. So volume of the sludge, normally volume formula is equal to, it is 100 minus, this volume formula is equal to, it is 100 by 100 minus P into M by rho sludge. Moisture content of the sludge, volume is inversely proportional to 100 minus P, right? When moisture content of the sludge increases, what happens to volume? Moisture content decreases, then 100 minus P value increases, then volume decreases. That's how reduction in volume occurs. Similarly, what happened? Oh my God. Similarly, what happens is, so this volume also straight away proportional to M. So because the change in M value also cause a change in M value decreases, volume also decreases. Similarly, so V is inversely proportional to rho sludge. As moisture content decreases, rho sludge increases, volume decreases. So every parameter in this equation contributing to volume change. Okay, that's how when we put sludge to treatment, volume reduction of the sludge occur. Every parameter contributes to volume reduction. Understood? Every parameter. So V is inversely proportional to 100 minus P. 100 minus P value increases, volume decreases. P is straight away proportional to M. M value decreases, volume decreases. P is inversely proportional to rho sludge. Rho sludge increases, volume decreases. That's how every parameter contributing to volume reduction. So whenever we go with the sludge treatment, huge amount of sludge convert into small amount of sludge. disposal becomes so simple and so easy. That's what happens. Okay? So these equations you have to remember. This V2 is equal to 100 minus P1 by 100 minus P2 into V1. In addition to that, exactly you want to work out, this is the one, V1 and V2. For V1, moisture content is different, solids content is different, this is different. For V2, P value different, M value different, rho sludge different. Independently you want to work out, you can work out. Or you want to link between them by making small assumption for no change in moisture content, no change in solids content. This is a slightly overestimated thing, but actual estimation is separately calculating and comparing is always better. Okay, but that is lengthy process. If for 1 mark exam, 1 mark questions, 2 marks questions, you can't expect to work out independently V1, V2 and work them out. That is too lengthy. Therefore, for linking them these two with the help of this kind of questions they are asking in the exam. Okay. So for example, you see, I'll show you one question. Okay, not required. Already we have solved so many questions. Similarly, in sludge digestion process, theory questions also they are asking nowadays. So what is the temperature at which this digestion we need to carry out? So sludge digestion slowly occur it depends on temperature. Temperature increases, time to carry out digestion decreases. So it is temperature dependent. We discussed already. Mesophilic range of digestion is there and thermophilic range of digestion is also there. So sludge digestion problems are important. So once you are familiar with this, then you can also design septic tank. Septic tanks questions also important for exam point of view. So volume of septic tank is equal to it is volume of settling zone of septic tank plus volume of sludge zone of septic tank. So volume of settling zone you can find out using detention time. Volume of sludge zone you can find out rate of sludge production into number of users into cleaning period. So using this equation, you are expected to work out certain things related to septic tank. That's all. So sometimes he will ask you what is the cleaning period required, right? Sometimes he will ask at what rate sludge is produced, or sometimes he will ask the size of the sedimentation septic tank. So once you get the volume, then you can find out length into width of septic tank is equal to volume of septic tank by depth of septic tank. You can find it out. Right, or volume of settling zone by liquid depth you can apply, you can work out, or the depth of settling zone you can take and work out. This length into width. Length into width ratio is given to you. Then from this you can find out length of the tank and width of the tank. So for a given dimensions expected to work out cleaning period or something like that, or for a given design parameters like detention time, cleaning period, rate of sludge production, you are expected to find out length of the tank and width of the tank. This kind of questions they will ask. Okay. Coming to oxidation ponds, again there also only one equation you need to remember to design oxidation ponds. Size of the pond is equal to surface area of pond is equal to, this is nothing but size of the pond, L into B, which is equal to total BOD applied to the pond, influent BOD by, it is BOD loading rate or organic loading rate. So based on this, you will get L into B ratio. Using L is to B ratio, you can find out length of the oxidation pond and width of the oxidation pond. Then using detention time, you can find out volume of oxidation pond. So volume of oxidation pond is equal to, it is length into width into H, right? Therefore, depth of the pond is equal to, it is volume by surface area. This will give depth of the pond. That's how oxidation pond questions they will ask. Oxidation pond questions, they link with the BOD problems also, by linking this parameter. So our BOD removal efficiency of pond is equal to, it is Yi minus Ye by Yi into 100, right? This is the one thing. And detention time of this pond approximately you can find out by 1 by K into Ln Yi by Ye. If Yi and Ye values are known to you, you can find out detention time. So total BOD applied to pond is equal to, it is Q into Yi applied to pond is equal to Q into Yi, which is also equal to population into per capita BOD. If you have all these points in your mind, any question related to oxidation pond comfortably you can work out. Okay? Any question related to oxidation pond comfortably you can work out if you know all these points in your mind. In addition to this, then what is important topic is disposal of effluent. In disposal of effluents, very popular question is, what is the BOD remained at so and so distance after disposing the waste into a river? A river is there flowing here, right? You dispose a Q amount of waste into river with so and so BOD, right? Or it may be ultimate BOD, or it may be 5-day BOD, whatever it may be. All should be in same unit system. So and so BOD of wastewater, it could be ultimate into a river whose upstream side flow is Q, or whose upstream side BOD is BOD of river. Then what amount of BOD, right, at the downstream side? This is upstream side, river, this is assume that the river, this is on the downstream side at so and so distance, so and so kilometers on downstream side, L kilometers on downstream side, what amount of BOD remained in the river at L kilometers you are expected to work out. If that is the case, how to find out? BOD remained at any time is equal to this is L0 or L mix, otherwise I'll take it, okay. I'll take it as a concentration. It could be BOD or any parameter. Concentration of wastewater, this is concentration of river water. So after mixing here, this becomes C mix. So C mix is equal to, how to find out? Q river into C river plus Q wastewater into C wastewater by Q river plus Q wastewater. C mix. That C mix value keep on decreases as it river travel downstream side. C at any time is equal to, it is C mix into e power minus k into t. This t is equal to distance traveled on the downstream side by velocity of flow. Velocity of flow is equal to q by cross section of river. So it is area into length of the river by q. So A into L is equal to cross section of river into length, distance on the downstream side it is. Right, you will get t value, then substitute that k value. K is not rate constant, it is whose value is given to you. Right, if you multiply into that, you will get that one. If it is BOD, BOD mix. If it is chlorides mix. So any parameter, as it travel more and more on the downstream side, its concentration keep on decreases. Based on this equation, nowadays he is asking questions in GATE exam. The past 6-7 years he is asking 3 times this question came. How to work out concentration on the downstream side at so and so distance after disposing the waste. It could be any parameter. If it is ultimate BOD, we work out in terms of ultimate BOD. If it is 5-day BOD, we work out in terms of 5-day BOD. Usually, BOD remaining you have to work out. L value you have to work out. Okay? Sometimes he will give ultimate BOD here and 5-day BOD here. So 5-day BOD you convert into ultimate BOD and work out. BOD remaining you have to find out, not BOD removed. So if they ask you BOD value on the downstream side, means it is BOD remaining at any time. It is L0 of mix into e power minus k into t. Using this expression you can find out BOD remaining at any time t on the downstream side after disposal. Okay? Remember this equation. In addition to that, general mix equation I wrote here. For any parameter, mix formula, how to work it out. That is also important. Okay? And Slitterfell's equation, no way. But in the last year GATE exam, you asked this question. When you plot Ogden-Sack curve, this is called Ogden-Sack curve. This Ogden-Sack curve is used to measure DO on the downstream after disposing the waste. Okay? So this is DO at any time t is equal to, this is dissolved oxygen in the river water at any time t, and this is called the deficit of oxygen at any time t. So in one last year I think initial deficit 2019 they have asked this question D0, that initial deficit of oxygen is equal to D0, deficit at any time is dt, and critical oxygen deficit is maximum deficit, that is dc. So initial oxygen deficit, how to find out? Initial oxygen deficit is equal to is D0, which is equal to DO sat minus DO mix. After disposing the waste, what amount of DO is there? DO sat is this one. DO at saturation. This is DO at sat. So DO sat minus DO mix. This is DO mix. This value is DO mix value. This value is DO mix. So this is DO sat. This value is dV sat. So dV sat minus dV mix will give d naught. This d naught. Understood? This question was asked in GATE exam. And in addition to that, deficit of oxygen at any time t, that is impossible. That is a long equation is there. So such type of questions no way in GATE exam. So this is about wastewater engineering. Then last is solid waste management and air pollution control. Solid waste management, very popular topic is that oxygen demand. Solid waste management. One question students often confusing is that what amount of oxygen is required to decompose solid waste. So sulfur react with oxygen converted into sulfur dioxide. Nitrogen react with oxygen into converted into nitrogen dioxide. Like this, different components are present in solid waste. Carbon react with oxygen convert into carbon dioxide. Then what you need to do? What amount of oxygen required? What amount of air is required to oxidize this? Because if oxygen content in air is some 20%, 30%, 21%, something like this question is being asked. So what amount of air is required to decompose these substances? So S and C are the substances present in waste which are consuming oxygen. In that case, what you need to do? Sulfur require this much amount of oxygen, nitrogen require this much amount of oxygen, carbon require this much. So using their molecular weight you require. Sulfur molecular weight is 32, right? Nitrogen molecular weight is 14, carbon molecular weight is 12. So 32 parts of sulfur require 32 parts of oxygen. Oxygen molecular weight is 32. 32 parts of sulfur require 32 parts of oxygen to convert into sulfur dioxide. Okay? Similarly, 14 parts of nitrogen require 32 parts of oxygen to convert into this one. Carbon require 12 parts of carbon require 32 parts of oxygen to convert into carbon dioxide. So therefore, how to find out oxygen requirement of these three substances? Using their molecular weights. So 32 parts require 32, one part require 32 by 32, so and so amount require how much? So oxygen requirement of sulfur is 32 by 32. Oxygen requirement of nitrogen is 14 by 32. This is oxygen requirement of nitrogen, sulfur. Oxygen requirement of carbon is 12 by 32. Right? This will give total oxygen requirement. And so on so waste. Suppose 1000 tons waste means multiply with 1000. You will get oxygen required for sulfur, oxygen required for this. Then once you get oxygen required, then air required is equal to oxygen required by percentage oxygen in air. So air required is equal to decompose that waste is solid waste is equal to, so total oxygen required by percentage oxygen in air. That will give air requirement. This question they have asked last time or 2 years back I think. So students are confusing. Nothing is they are using molecular weights, you can link them. Okay. In solid waste management, very important thing they are asking nowadays is that is design of landfill they are asking. Design of landfill means finding the volume of fill or area of fill. For this what you need to do is total weight of solid waste generated, right, in a given time you work out. That is rate of generation into population into number of days for which that fill is to be designed. You will get so and so kilograms. Then density of compacted solid waste in the fill will be given to you. Using this density, then you can find out volume of compacted solid waste in the fill. Compacted solid waste in fill is equal to total weight of solid waste generated by density of compacted solid waste. See the units will get. This in kilograms, this is kilogram per meter cube. Therefore, you will get volume of solid waste. If fill is completely packed with solid waste, volume of fill is equal to volume of solid waste in the fill. So volume of fill is equal to volume of solid waste in fill. Already got this. Then once you get this, you can find out area of fill. So just you have to use your common sense to design them. This is called engineering aptitude. If you have engineering aptitude, you can work out. You don't have any principle or something like that. Just arranging the data. Volume of fill by depth of fill will give area of fill. Okay, this is how we can find out. Solid waste management problems are so simple and so easy. Similarly, solid waste is heterogeneous mixture of so many number of things. So what is density of solid waste? percentage of component 1 in solid waste by specific gravity of component R. Okay. And find out specific gravity first and then density. Specific gravity of solid waste. Percentage of component 2 in solid waste by specific gravity of component. I told you, specific gravity is finding one question you will get. Percentage of component 1 by specific gravity of 1. So solid waste is heterogeneous mixture of too many number of things. Paper would be there, right? Cloth would be there, wooden pieces, metal pieces, plastic, right? Food waste, leftover food waste, all of them put together, it's called solid waste. So all those individual specific gravities are known to you. Using them, you can find out. Sometimes they are asking energy content of solid waste. Energy content, if they ask, percentage of individual component in solid waste by respective energy contents of them into 100. Sometimes they ask percentage moisture content of solid waste. Similarly, individual moisture content of individual components by their percentages will give this one. Pi is equal to percentage of ith component of solid waste. Pi is equal to energy content of ith component. If you sum up all those things, you will get that. Similarly, moisture content of ith component is MCI. So when you dry it, then it becomes energy content increases. Energy on dry basis is equal to this energy as discarded. This is called energy as discarded. Without making any changes, this energy. Okay? Energy on dry basis is equal to energy as discarded into total energy as discarded 100 by 100 minus percentage moisture content of solid waste. Energy on ash also if you remove, then that's how energy content still increases. Ash free energy and ash free dry basis. Ash also removed from the solid waste. Moisture also removed from solid waste. Energy still increases. Total energy as discarded by into 100 by 100 minus percentage moisture content minus percentage ash content. So these equations you have to remember. Then comfortably you can answer questions in solid waste management. And coming to air pollution, concentration of that conversion of units, concentration of these air contaminants, converting from one unit system to other unit system, that question is very popular. So I'll write that question. After that you need to know the effect of different components of air contaminants. Health problems, other problems, those things you have to remember. And that ELR, ALR concepts, how it influences the atmospheric stability, those components you have to remember. Then in addition to that, air pollution equipment like electrostatic precipitators and fabric filters, you have to remember them, that's all. So concentration of air pollutants, so that you can work out by using one expression. So ppm of any air component is equal to 1 into m by k into 10 cube microgram per meter cube. Converting ppm to microgram per meter cube, and 1 microgram per meter cube of any air contaminant is equal to 1 into k by m into 10 cube ppm. This is very, very popular conversion. They are asking, keep on asking questions in GATE exam. Conversion ppm to microgram, microgram to ppm. Similarly, 1 ppb of air contaminant is equal to 1 into m by k microgram per meter cube, and 1 microgram per meter cube of any air contaminant is equal to 1 into k by m ppb. Remember this, k is equal to some constant, that is whose value we work out by RT by P into 10 cube, where R is equal to universal gas constant whose value is equal to 82.05 into 10 power minus 6, and T is temperature in degree Kelvin, P is equal to pressure in atmosphere into 10 cube. If you can work out K value, and M is equal to molecular weight of any gaseous air contaminant. molecular weight of gaseous air contaminant. Carbon dioxide means molecular weight of carbon dioxide. Nitrogen dioxide means molecular weight of nitrogen dioxide. You have to substitute. That's all. In addition to that, ALR, ELR concepts are very, very important. ALR and ELR. So ALR is always equal to minus 1 degree Celsius per 100 meter, but ELR is sometimes greater than ALR, sometimes ELR is less than ALR. This you have to work out. So ELR is equal to environmental lab state, which is equal to dt by dz. dt by dz is equal to, it is T2 minus T1 by Z2 minus Z1. Slope of temperature profile of vertical atmosphere. This is a temperature versus altitude profile. This is altitude in kilometers normally, temperature in degrees Celsius. Based on this difference between ELR and ALR, what height these air pollutants rise in atmosphere? That one question they are expected to calculate. If temperature profile of that air parcel is at so and so, what is temperature at so and so altitude? If it is following ELR, it is following ALR, what is it? Like that questions they are asking, okay? That's it. This much idea is there. In addition to that, air quality, air pollution equipment like electrostatic precipitators, fabric filters, right? Small questions related to them. Electrostatic precipitators. They are asking. So just go through them, that is more than sufficient. So noise pollution topic is completely removed, you can ignore that, okay? So the 1 hour, 2 hours, so you can't discuss all these things. And over and above, I'm shy of camera, so I can't teach you properly in live classes like this. In the focusing lights are there. I can't do justice to you. So if you want to learn properly subject, you better attend either online classes, regular course, or otherwise offline classes. So anybody want to avail some offer is there, 15% offer is there, right? So you can use that offer and you can avail that. Better is attend classes. 2 hours, 1 hour, you can't learn anything, okay? Thank you very much for your patient listening. I think you are listening. You are not hearing. You are listening, right? Okay. Thank you.